and welcome to Maths Appeal. I'm Susan Okereke.
And I'm Bobby Seagull.
And we are two maths teachers that want to show that maths is for everybody. We love maths and we want everyone to love maths.
That's exactly true. And couldn't put it better myself. And our aim of this Maths Appeal podcast, this is like Susan's word, but it's to demystify maths, because a lot of people have misconceptions and misperceptions of the subject. But we're trying to show people actually something that can be doable.
And every episode we set and do a maths problem and we go through the solution with an aim to getting you to do that as well.
Yeah, that's maths is done by doing. And every episode we also discuss something that's sort of caught our eye in the real world, because maths is everywhere. And in this episode, it's gonna be a titanic discussion. It's metric versus imperial measure.
Oh, I see what you did there.
Yes.
Yes. In this series, we talk about problem solving and mathematical thinking, and we want to again showcase this through the different things we talk about, but also the different problems that we kind of work out and show how we work them out.
Yeah, and then we always say actually the best way to do problem solving is to actually attempt it, not just read about it. So actually you need your pen and paper handy at some stage.
Yes, you do. And we also want to show that it's fun. We want to show that it's collaborative. Hence, we're doing it together. We want you to share with us what you have done, even if you've got it wrong. Mm-hmm. And we also want to show that it doesn't matter if you do make mistakes. It's great for learning.
Oh, and again, we'd genuinely be delighted to help you. If there's any specific skills you want to learn, again, tweet us at Maths Appeal. Again, if there's any specific subjects in maths or problems you want us to cover, just let us know.
As we said before, every episode will feature a maths question, which we'll go through together. And if you've been listening to earlier episodes, you'll already know the drill. But just in case this is the first time you're checking out Maths Appeal, these are the questions that we ask ourselves for each problem. So to start, before you do any maths, the first thing you should ask yourself is, how do you feel when you first hear the problem? Then the question is, does the problem make sense to you? Are there any questions you have about this problem? And then what math topics are in this question?
And then, when you're actually putting pen to paper, so while you're doing the problem, you think about what facts do you know from the problem? Then you think about the rules of formula that you might need to help you tackle it. Then actually, are there facts you can derive from the problem itself? And then finally, are you in a position to answer the question? So, Susan, are you ready? Are we ready to tackle this week's problem?
Born ready.
Yes, always. So we're going to get stuck in right after this.
Our problem for today's episode is: in Bobby's kiosk, apples cost 45p per pound. And by that, I mean weight pounds. In Susan's mini-mart, apples cost £1.05p per kilogram. 1 kilogram is equivalent to 2.2 pounds in weight. In which shop are apples better value for money, Bobby's or Susan's? I'll repeat the question. In Bobby's kiosk, apples cost 45p per pound in weight. In Susan's mini-mart, apples cost £1.05p per kilogram. 1 kilogram is approximately 2.2 pounds in weight. In which shop are apples best value for money, Bobby's or Susan's?
So we're going to tackle that in a jiffy, but while you're thinking about that, we're going to talk about the big debate, metric versus imperial. The reason we are having this discussion is at the time of recording in June, there's ongoing discussion in the government about bringing back imperial measure. So at the moment, if you go to most shops, supermarkets, you'll find things in grams and kilograms and meters. And there's nothing to stop you personally converting into imperial measurement, but now shops will be forced to have an equivalent, potentially equivalent in the imperial unit.
I think we're in quite a funny situation actually in the UK. We're a bit of a hybrid of imperial and metric, because we do things like miles and we also do things like kilometres and things.
So now it's a good moment to give people some definitions. So the metric system actually started in France in the 1700s, and it's based on for the length, the meter, for weight or mass, the gram, and for volume, the liter. Actually, the word metric, you don't have to be Sherlock Holmes to work out, it comes from the word meter. And what's lovely about the metric system is that there are prefixes that can make things bigger or smaller. So, for example, with gram, if you put the word kilo in front of it, it makes it 1,000 times bigger. Or you've got mega, giga, tera. And then for smaller, you can make it milligram or micro or nano. And these ones are specifically multiples of 1,000. For example, a milligram of medicine, that's like 1,000, or a gigabyte of computing power. And the metric system is in decimal because it's based on powers of 10. But that's not the same for imperial, is it, Susan?
No, the Imperial is a bit more. Well, it's not decimal. It's a bit kind of more all over the place on some level. You've got terms like for length, you've got inches, foot, feet, yards, miles. For weight or mass, you've got ounces, pounds, stone, hundredweight, which I've never heard of. Wow. And then for volume or capacity of volume, you've got ounces, pints, quarts, gallons. And so here are some of the conversions that you might or you might not be aware of. So to go from how many inches are in a foot? I don't even know.
Oh, so in 12.
12, yeah. And then and there are 3 feet in a yard.
Yes.
And so and then I think it's something like 12 ounces in a pound or something.
Yes,
and then 20 pounds in a stone. I don't know. But the issue is it's not as straightforward as in metric you multiply by 10 or divide by 10 or 100 to be able to convert between them. This one, there are certain amounts within each one, but it varies and it's not that uniform. I think it's fair to say, Bobby.
Yeah, it's very strange. Like, I guess it's one of the things, if you're used to it growing up, our parents and grandparents' generation, they will probably quite comfortably reel things out. But for us, it feels a bit archaic. Although it's used, like, for example, I'm a big football fan, and you got the 12-yard line, penalty spot, or 18 yards, the edge of the box. Or the marathon is 26 miles.
But I think that's the thing in the UK. It's interesting because we use metric, but most of us when we think about distance, we're thinking about miles with regards to miles per hour. Also, think about height. I think of myself. I'm 6'7".
I'm 5'11".
Lol. So like I think I'm like 5'5". 5'6", and I know what that is. That's 5 feet 5 inches. And so that what's interesting about that is like I can see that quite clearly, but I don't actually know what I am in meters or centimeters.
Yeah, it's an interesting one because I've heard people actually defend the imperial system because it's easier to divide things up. Like for example, it's 12 inches in a foot.
Yeah.
So if you have 1 inch out of 12 is 1 out of 12, 2 inches out of 12. Divide, what's 2 out of 12 simplified?
Oh, sorry, 1 out of 6.
Yeah, 3 inches out of 12, simplify that.
Okay, you're saying this to me now, but do you know how many? Actually, I found somewhere that there are 16 ounces in a pound, 1/6, and then there are 14 pounds in a stone. So how do you convert from ounces to stone?
Okay, so some of those I can't defend the entire system, but there's a case. The decimal system with 10.
Yeah.
Only 1, 2, and 5 go into 10 neatly. So in terms of half, quarter. So in terms of like halves, quarters, thirds, in a weird way, having things like 12 or 16, it's easier to divide up into halves and quarters or thirds if you've got 12. So it's, I guess, like, why is it there in the first place? It's strange, but I can see some benefits in terms of listeners can't see this, but Susan's giving me the evil eye.
I'm not on the fence at all. I think it's I need to be careful, don't I? But I think it's ridiculous because you tell me, Bobby, how many yards are in a mile?
Is it 1568? No, what is it?
1,760. Who's going to remember that?
Clearly, I can't. I'm a quizzer, and I should have known that. But
yeah, 1,760 or 1,760 yards in a mile. So, I mean, I don't know. I'm a sucker for uniformity and easy conversion. Like, if I can multiply, divide by 10, 100, 1,000, count me in. As opposed to, so was it 20 fluid ounces in a pint? 8 pints in a gallon.
I mean, I guess mental dexterity. That's
I guess so. I mean, was it our producer Jenny told us something that her dad told her about? 1 pint is a litre. No, how do you
was
say
it
it?
1 liter is 1 pint and 3 quarters.
A litre of water is a pint and 3/4.
Okay, that's
Oh,
it.
a litre of water,
Water is a pint and
pint and
3/4.
3/4.
Thank
Thank
you.
you.
See, with these mnemonics, you've got to remember these eight memoirs. You got to remember it correctly, otherwise you.
Otherwise, you don't get it right and you just look like an idiot
Yeah.
in front of a microphone.
A liter of water is a pint and 3/4. If I remember
love
that,
that.
it's actually neat.
That's really great. Well, now we've passed on some good knowledge to people if we end up going to Imperial. So, and I think isn't it the whole idea that Imperial's to do with the British Empire? Is that the deal? Or?
Yeah, I guess, yeah. It's like it's not. It's used in some former parts of the British Empire, the Commonwealth, I guess, nowadays. But the reality is, the world is slowly going to end up completely metricized.
When you say slowly, I'm saying most of the
Very
globe
quickly.
use
Do you wanna say,
metric.
very
Yeah,
quickly. I think again I've used a warp because we're used to things like a pint, and I'm like 12 stone now, or I'm 10 miles.
are you?
No, I'm not. I don't know what I am actually. I think in kilograms.
Well, this is it. Well, okay. I mean, maybe that's one of the polls. Maybe we should do a poll about this. I'm interested to know what people
shall
actually
we?
think about.
Yeah, maybe we'll do a master appeal poll.
Yeah.
Imperial or
Metric.
or both.
Blended. Yeah. Well, as we are. I mean, because we're currently there anyway. And I
Yeah.
think, do we need to fix this? How bad is it? I mean, to be honest with you, as a teacher, as a maths teacher, I really, 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 really want the students I work with to understand the conversion between the different metric units. So, for example, meter, understanding that kilometer is 1,000
Yeah.
meters, and kilo means 1,000.
Yeah, the
Centimeter
prefixes.
is 100th of a meter, and that centi is 100, so it's 100th. Milli is 1,000th, and it's this idea, if you can understand those words, because then you could then use that information of knowing what the prefixes are to grams. So what's a kilogram? A kilogram is 1,000 grams. What is a centigram? I mean, is that a thing? But that would be 100th of a gram. Milligram is 1,000th of a gram. Like, this is, if you know these words, suddenly all this stuff is like open to you, and it's useful and easy to use, which I don't foresee that as a thing with regards to
Yes, I think you're right. So maybe if we're putting our efforts into teaching weight and measure, it should go towards something which has a logical scale that students can apply across. And if all of us can apply across the board to weights, lengths, and volumes, rather than having to learn a separate one for every single. So yeah, I'm sorry, Maths Appeal team. I think we appreciate the odd Imperial problem, but we're team metric here.
Team metric. Well, obviously, we'd love to hear your opinions, and that we might actually put a little poll out. That's a little work to do. Do you think we should remind people then of the problem? You ready, Bobby, for this?
Yes.
In Bobby's kiosk, apples cost 45p per pound. By that I mean weight pound. In Susan's mini mart, apples cost £1.05 per kilogram. 1 kilogram is equivalent to 2.2 pounds in weight. In which shop are apples better value for money? Bobby's or Susan's? Okay, so that's the question. Are we ready? I have to say, I found the problem a bit easier than reading it. Reading it was quite challenging, actually.
That's fair.
So let's go through our prompt questions. Bobby, how did you feel hearing the question?
A bit like, oh no, not one of those.
Oh, really? Yeah, okay.
Just like,
yeah.
just like one of those. One of those conversions.
Yeah, I know. I'm not a massive fan either, especially because I don't mind conversion in metric, which I think I've said I'm a fan of. But when it comes to metric, imperial to metric, or metric to imperial, there's a sinking feeling in me. And I also know that the kids I teach, it's almost a no-go. And so, did it make sense to you?
So I think upon inspection, yes. I think the first time you just see like pounds, weight, kilograms, and you're like, I'm not liking this. But when you actually start working out the key bits of the question, the ratios actually sort of make sense.
Yeah, I think it's. I would also say that it's probably better to look at than it is to listen to, with regards to the pounds and the pounds. You know what I mean? The,
Oh, yes.
Yeah. So that's a thing. And then the maths, I guess the math topics in there are you've got mass, different units of mass, converting between different units, but also money as well, and converting
Money
between
as well, of
different
course.
units of money in there as well. And then proportion, again, which
Yes,
comes up
quite a
quite a
few
lot
different topics.
in this one simple question. So, shall we think about what facts we know in the problem? So, how do you go about it, Bobby? What's your strategy?
Just like my student just randomly put in like divide, multiply, hope something makes sense. No, I'm a professional teacher. I don't do that. So the key bit is in the question. It says 1 kilogram is 2.2 pounds. Without that, I'll be honest, I wouldn't have been able to solve it independently.
Do you know back in the day, older GCSE questions they didn't give you the metric conversion, so they'd say find it in pounds, or whatever. Or they wouldn't even
and
tell
you
you
had to-
about the 1 kilogram
You
to
have to
2.
know that yourself, okay?
Yeah, bruh. Yeah. So what did you do?
So first thing is, so if it's 2.2, it's almost like setting it up as a equivalency.
Yeah.
So you know that the 1 kilogram is 2.2 pounds. So the pounds, we need to convert that, almost like the amount you're paying into the kilogram amount. I'm hoping I'm getting this correct.
Yeah, go on.
This is where like my working gets it's a bit tenuous. I said you multiply 45 pence per pound by 2.2. Am I on the right track here?
Well, yeah. So what? Yeah, that's pretty much what I did. I said that 45p is equivalent is £1 in weight,
Yeah.
and then I wanted to convert my pounds in weight to 1 kilogram, because then I wanted to. So then I could compare it to the kilogram of the £1 and 5p. So that the key issue you have is that they're not the same amount in weight. Does that make sense?
Yes, because I'm obviously selling smaller portions in my kiosk per pound, because yours is in theory, or the way in which we advertise it, yours is advertised per kilogram,
Yeah.
mine's advertised per pound.
Yes.
So then we have to do the conversion. Because honestly, this question here does my head in. Genuinely.
Okay, good. Bobby, you're not enjoying yourself. Should I talk you through what I did?
Yeah, because
And-
I guess it's one of the things, I get an answer,
Yeah.
but I actually when I teach this topic, I don't fully feel comfortable.
Oh, yeah.
Because I can do it, but like if I had to explain exactly why I did it, I might need your help.
Okay. You're going to have to help me in a number of occasions, I am sure. So, the key thing whenever I think about this, it's like to be able to compare anything, and two things, they have to have something that's the exact same, and then you can see whether the values kind of match up. Okay. So the key issue that we've got is that what you're selling is in pence and pounds, pounds in weight, and what I'm selling is in kilograms. So we can't say £1 and 1 kilogram are not the same. So we cannot say that we don't know whether they are the same. Which one is better? So we have to scale one of those up or down so that we have the same weight. And whatever we do to the weight, we do also to the cost, because it's in proportion.
So it's almost like a set of scales, an equation.
Yeah.
You just it's just like algebra, like do to one side, do to the other.
Well, I don't like to think of it as I generally think of it as a diagram. So I like a diagram.
Of
You'll
course,
see
yeah,
the box. So my thing is it's going from £1 to 1 kilogram, and we're using our equivalents, which we know that 1 kilogram is actually 2.2 pounds in weight. Yeah. So we want to know how much that will be. So in your shop, say I've decided to convert your shop apples to kilograms. That's what I've decided to do. Yeah.
Okay, so you got that 45p.
Yep. And I'm going to
scale
scale it up to get in your shop. If I was to buy 1 kilogram's worth, how much would that be? And then I can compare it to my shop. Yeah. So to go from your shop of 45p in one pound to get to 1 kilogram, I'm multiplying by 2.2, because that is 2.2 pounds is the same as 1 kilogram. Yeah.
Yes.
So I've scaled it up 2.2. So I've multiplied 45p by 2.2, which is if I went to your shop and I wanted to buy a kilogram of apples, I would pay 99p.
Yeah. I get the same answer, but I need to check myself in terms of how am I setting it out.
Okay.
Yeah, because like I think yours is clear in terms of you're trying to. I think for this a diagram does help.
Yeah, and I can show you what I've done. But the key thing is the thing you have to have in your mind when you're asked a question like this, or even when you go to the shop in real life, and you're asked what is the best value. The only way you can do that is to compare the two things or three things by the same amount. So if something's being sold for 100 grams, something else is 200 grams, and something else is 300 grams, you want to scale them up to the same amount. And then you can see how much does that amount cost, and then you can know whether which one of them is the best value when it's been scaled that way. So you have to work out what that thing is.
It's a good problem. It's definitely it's less so nowadays, but it definitely used to be a real problem, and it could be again.
But there's more. But it's also one what I did was scaled up to 1 kilogram. You could also scale down to 1 pound.
So divided by 2.2.
That's it. So go to my shop and then divide by 2.2 and find out what equivalent of 1 pound in weight is. And I think that's 47p something. So that tells you. So it's still, because it will still work out whichever one's the best value will always be the best value. It doesn't matter what you buy. So I'd be interested to know how people did it.
Yeah, it's a good. Again, it's something that you'll see in shops with the scales and the, like when you go to the supermarket and you're measuring. Do you know the old ones where you'd measure like apples in a basket and you'd actually drop it down and you'd see the needle move.
Yeah, I do remember those ones. What's funny, Bobby, is I try and teach solving equations with the balancing thing, the balancing of weights. So it's like, think about, you take one from the other end. And I say this to kids, and kids are like, they've never seen those. They own their digital weights.
It's
so
digital, I know. It just changes the way people think.
Yeah, so I do know what you're talking about, but some people of a younger generation might not. But as always, we'd like to think about how this could be extended. What kind of other questions could you ask around this question? You could do loads. You could just vary it up and add in different currencies.
You put grams instead. You could put instead of pounds, put stone. Just different measures of weight. Yeah.
But the key thing, I suppose, is making sure you understand that what you need to do is be able to compare, get two quantities to be the same, then you can do the comparison.
It's a good. I think it's I don't like these problems, but it's weird. I don't like them, but I like them because it feels like this is like conversion.
You're working.
Now, do you know once a spacecraft by NASA, I think, ended up in the wrong place because they put miles instead of kilometers.
Yeah, there's a thing
in the late 90s.
Our friend Matt Parker has done a whole book on those mistakes.
Oh yes, he's done a whole book. Yeah, Humble Pie.
Humble Pie, indeed.
We'll meet later on in the series.
You're in for a treat, Bobby. It's time for the maths facts. What have you got for us today?
So we're talking about metric stuff. So we're gonna go look at what the meter is. So our friends in France in 1793, they actually defined. So French astronomers defined the meter back in 1793. So back then it was 1/10,000,000th of the distance between the equator to the North Pole. So from the French meridian, so like in France, from the equator to the North Pole, it's called a great circle, but essentially it's 1/10,000,000th of a specific distance is a meter. Well, it was, because nowadays everything is like been converted to like either based on the speed of light or on electric currents, but it used to be a physical actual distance. And in France, they got something called the mètre étalon. And there's actually a small shelf that's made in marble, and it's in the Senate or near the Senate in Paris. And they had 16 of these installed around Paris by the Académie des Sciences. And these are, people can go and literally measure, this is what a meter is. The mètre étalon. Unfortunately, only 2 of these still survive, and only 1 in its original position. But back then, people, if they wanted to measure a meter, they'd go to the mètre étalon near the Senate in France, in Paris, and that's it. That's the meter, which is 1/10,000,000th of the distance from the equator to the North Pole.
Well, I mean, it's funny because you mentioned in a previous episode the grand K, as in the weight of a kilogram. So was France just all about measure?
France was the boss, to be honest, in the late 1700s in terms of chemistry and mathematics.
Wow. So you can still see these.
There's 2 of them still there. And that is the official original. It's not anymore. Now it's based on the speed of light. But back then it was just an actual physical distance. It's weird. Light is, It's not a physical distance anymore.
Again, another time you've blown my mind. We also want to hear from you. If you've got maths facts, if you have got a solution to share with us, get in touch with us at Maths Appeal on Twitter and on Instagram.
And obviously, email. We always take emails at mathsappeal1, that's number 1, at gmail.com.
Because we want to hear from you, because you've heard from us. We'd love to hear from you. And thanks again for joining us and, for listening, and for taking part.
So you've been listening to Maths Appeal with me, Bobby Seagull and Susan Okereke. And the music's been composed by Kelly Okereke. The image designed by Calix Davis. Our wonderful producers, Jenny Nelson. And we will see and hear you in episode 7 for more maths problems that we'll solve together.